This is one of the example of denormalization. So we have a sales master table. Okay, basically it's a sales master table where we have transaction date, item name, item category, cost, customer name, email address, postal address. So what we have here is like, let's say this is kind of a store where a customer is purchasing the products. Okay, they might be purchasing on a daily basis, on a regular basis, right? So within the same day, they can have also purchased multiple times, right? So if you look at this highlighted yellow color one, Emily Brown, this customer is basically has bought some products over the past, few months, right? Like last time she has bought this product on so and so date, and the product was microwave, and her name is same, like the customer is the same customer, her email address is same, her physical postal address is also same, right? But again, when she has purchased another item, again we are kind of repeatedly storing the same information. So basically the information is being repeated rather in real time. Like if you are talking about big databases where they have huge tables or huge number of records, ideally we see it's a very long table where you have a lot of the columns in there, and a lot of information is being repeated, right? So uh, so there is always a possibility to make this table a better one. So right now we don't see any issue because it's a very small table and we can quickly import and build a proper Power BI report out of it, and we won't see any issue in the performance as such. But when you are dealing with millions of rows, right? You're dealing with millions of rows, having a single table with these many millions of records, and knowing that you are kind of duplicating this information and again is kind of a not well suggested. Okay, the problems with denormalization is basically we have data redundancy, which is kind of same information is being repeated many a times, right? And also over the time it increases the storage space. Okay, not only that, it is very difficult to update. So if you look at the table closely, right, it is very difficult to update. So if you want to update this address, and imagine after millions of records in one single table, and imagine this person has bought like over hundreds of times and 20 different products, and updating the information across all of those records is really difficult, right? And also sometimes we need to change their email address, sometimes maybe they change the physical address, or maybe if you wanted to update some other thing, it is very difficult. Okay, and adding and removing stuff is tough, right? Putting new information in or taking it out can be confusing because it's in so many places, right? Affects speed and makes things complicated. uh, so basically while searching for things might be faster because all of them are into one single place, but managing all the extra copies makes things more complex and slower when updating. Okay, so denormalization, in some extent, if you are looking from the database administrator perspectives or database, modular perspective, if you are coming from database team, maybe sometimes denormalization is having a couple of benefits, like it improvises the speed of access in some cases, but ideally in the reporting side or in the BI side, it is not well suggested to have a denormalized table. You always wanted to go with a normalization table